Hello, and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listener's ears to new and exciting technologies they may have not been purviewed to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between.
Industries and stuff like that, it's starting to become more and more Industry 4.0 relevant. You start thinking about, you got Relativity Space, doing, rockets with a, 3D printer. And that is collecting data as they build it and stuff like that for regulatory affairs and also for, pressure vessel testing and all the other stuff, But it's also controlled by, which we'll get to, down the road, is an MES system and a build system, SAP, and all the other stuff. So it's actively connected to all these systems. So it's actually Industry 4.0 controlled, as we start moving forward and we start talking about, stuff at a higher level. However, if we're starting to talk about like your hobbyist, printers and stuff like that, the stuff that most people are going to be into, they're not going to go out and buy the $200,000 printer that's connected to the network. But, they start talking about future proofing, because if you want to buy a $100 printer now, I want to keep the $100 printer for a while because I don't want to go out and spend another $100. Call me frugal, but that's just how it goes. But so John, when I'm starting to think about, future proofing and stuff like that, what's currently available?
Yeah, it's good points that you make as far as like, preparing. I don't want to spend and I don't want to purchase a second device just because the first one went down or anything like that. When I think future proofing and what's available, it's more of how can I guess we get into that preventative maintenance.
Yeah.
How can I make sure that, what are my points of failure? How can I make sure that those points of failure can say withstand more temperature, withstand longer print times, like, more sustained temperature, can withstand constant printing. So constant like raising and lowering of that temperature, those movements, those stepper motors, are those able to continuously drive, and does your extruder, does it have teeth that's going to pull this filament? Like, these are the things that are getting used the most. So these are the things that you should most likely focus on. If you can, upgrading stepper motors, honestly, they're not crazy expensive, but might be one of the more expensive pieces. The first thing I purchased, I think, was an aluminum extruder, because the one that came on the Ender 3 Pro was plastic. And that plastic, first couple prints already started degrading and already started denting and deforming, and it was going to break soon. Then you get into those dual gear extruders. It's pulling from each side instead of one side. You got direct drive extrusion, which is taking away that middle tube that's feeding filament in, and it's going directly into the hot end, so it can directly get that heat, and it's more of an efficient heat break in that sense. So there's pieces like we'll call them upgrades that you can do to ensure that your printer lasts a lot longer. And I suggest not kind of thinking about the things that you're going to use constantly. Nozzles, don't be upset if you go through a nozzle in a day. Nozzles are cents on the dollar. I suggest getting hardened steel, to be honest, though, if you want to print higher temperatures or more abrasive filaments. The print bed, I've gone through probably 10 print beds, from glass, PEI, spring steel to just the magnetic kind of like I don't know if it's flexible. I don't think it's silicone, to be honest. It's some type of material that's there that works as well. But so those pieces you shouldn't focus on as much. But your motherboard, get your extruder. That thing's pulling a lot. It's going to need to be looked at, and your hot end, because it's the one that's absorbing the brunt of the work, the heat. and it's what can go down first. So for me, future proofing, get yourself a couple extra nozzles, get yourself maybe 2 extra print beds. If you need, I would say maybe even a fan. You can get better fans. The stock fans are pretty cheaply made. I had to replace my fan in the first 2 weeks. So those are some of the things that like I would think of on a hobbyist side to maintain my device and future proof it. Oh, sorry, another big piece that I didn't think about. You should get an enclosure. It's good for the environment of your 3D printer to keep it that temperature and that environment closed, because you can also limit the deviation from your temperature that just can happen from natural everyday elements. So an enclosure honestly might be the first step. So I don't know, from the mechanical side, like these are all the working pieces that's why I changed those first. I noticed the degradation and the wear and tear on it first. But from a maintenance side or OT side, like what do you think, Ed, when it comes to future proofing?
Well, I would say for me, we know that most people are moving to a dual Z axis. So with a dual Z axis, I would say the motherboard itself should never be a limitation. We should build that functionality ahead of time and say, hey, yes, it costs a little bit more because we added some more connections. But with this board here covers if you want to add a second Z. This board covers if you want to add additional sensors. So we should be able to engineer in future proofing. The material that we use for the hot end, we should be using materials that are copper and coated with some special coating to compensate and deal with this heat that we deal with one of the most important parts of the 3D printer. Nozzles is another thing. Maybe it's better to just invest in a nozzle that costs you $20 per nozzle and it lasts 6 months, as opposed to buying a bunch of brass nozzles that if I want to do anything with carbon fiber, I'm going to only get one use out of it. So the end user has to quit thinking of a 3D printer as a consumer device. The end user has to think of the 3D printer as, hey, this is a commercial or this is an industrial device. So future proofing to me is make it industrial, make it robust, make it run. You can have a mechanical can opener or an electrical can opener. Both do the same thing, but which one is more efficient? Yeah. So efficiency should be built into these devices.
Yeah, you make a good point, actually, because we talk about the future proofing, Nick, and it's getting to an industrial standpoint. It's getting to, because what is production? You think about that. If you're producing something, when do you not want to be producing? You want it to always be running. So if I need something to always be running, well, I need to make sure there's maintenance on it, and we get back to preventative maintenance again. But it's if I need this to always run, I need to know what my most critical points are.
So I'll say it this way: how many times do you replace a washer and dryer? Over a time frame. Maybe you get 7 to 10 years out of washer and dryer. What about a microwave? How many people hey, I got to replace the microwave? So I'm saying you build the device so it's robust.
Right.
And Nick, and you can continue and let Nick chime in too. But I think that's the difference. Quit making stuff that's made out of paper and make it out of metal.
Right. It's like, if you can, make things out of a, hardened, piece of equipment, steel, aluminum, whatever. Hell, you can make it out of glass if you really felt like it, as long as it's tempered. It's, reliability, especially if you're using something that's, at a higher strength standpoint, it can withstand the overuse. And also, most of those higher strength metals, when you start thinking about it, are self-lubricating anyways. They are able to withstand the lubricants and stuff like that. If you think about it, raw aluminum is not, self-lubricating at that point. Hardened aluminum and stuff like that can be, because you can add in the coatings and stuff like that do it during the treatment process. So it's constantly got a layer of slick on board to make your rollers speed up and slow down. Is that's why we do chrome lined or chrome covered guide rails and stuff like that, because those on their own is going to provide a slick surface for forward and backward movement. But it's kind of funny that because most of that can't be controlled unless you got software on board. You look at the different firmwares and stuff like that we've got. Every single printer is going to run on a different firmware. However, they can all run on the same one if you really felt like it. If you kind of knew what you're doing, everything can be on the same firmware. And that to me is another future proofing thing. If everything can be run on one firmware, then you only have one code base you have to update, one thing you have to test, one thing you have to validate, and everything works from there. It's like, I know there's different things out there, and I know John, you can chime in on this one. Is the different softwares that we have that can actually help you control those printers from a distance. Let you know when you have a problem. Give you the ability to hook up, MQTT or a unified namespace to your 3D printer, and allow you to watch that data in either Power BI if you're using Windows, or if you're using something else. You can use Kibana or the Elastistack to build an MQTT monitoring dashboard for the Raspberry Pi that tells you what your hot end speed of your hot end is, what your speed of your motors are, and that kind of brings us also to a point where you have to start thinking about when do we get our X and Y and Z access drives to the smart drives that we have now in manufacturing, where the drives themselves have MQTT on board. You're not really adding that much. If anything, you can add a Raspberry Pi Pico to it, turn on Raspberry Pi, and let her rip, tater chip. And now you have a drive that reports every time you get above a couple hundred RPMs. And even though most of those run at a couple thousand RPMs, but once you exceed nominal limits, it'll report. If it has an issue with the brakes, when it locks in a brake for it to not move left or right, it should automatically report telling me there's a problem.
Right. Or stopping the system if
right.
you breached like a safety or something like that.
Right. Exactly.
I want to, and I don't know. I'll jump in because I want to talk about OctoPi and OctoPrint, but then I'm going to go over to Ed after this to kind of get his thoughts on it. But there is an environment. Mm-hmm. There is software, and I'm not saying it's the only one. I think there was another one. I can't remember the name off the top of my head, but OctoPrint was the most recommended. It's a Raspberry Pi image, and they have their own website. They walk you through. It's all open source. You can go and download their image, put it on a Raspberry Pi, preferably a 3B Plus or higher or newer. The older versions can't really run it. They don't have the processing power. But load it on there. You'll pick and create your user account and your admin account. And then from there, you use your, whatever IP address you set for it. Most of the time is your external IP, which is the set IP for your home. You would connect to that. You put that in your URL of Chrome, Firefox, whatever you use, Edge, and it'll connect to an OctoPrint server. You've created a server. And that server itself, the OctoPrint, if you connected that to a TV, it's going to be a command line interface. It's going to tell you where to go, where you can connect, how you can connect. And I'm assuming, I haven't dug as much as I would like to into that, but I'm assuming that's where some of my time lapses end up living, so I can go find those files and move those over to, let's say, my Windows, or if you have a MacBook, a Mac, so that you can do, post-processing, or if you're trying to save those files, you can kind of have those. But OctoPi itself, it can be connected to many different APIs, different plugins that do your MQTT protocol, subscribe and write. It'll do, so you don't even, you can probably get the middleman out and not even worry about the Elastic stack or any of the Kibana logging or anything like that. I mean, you could, I mean, it'd be nice to have more information on everything, to be fair,
Yeah.
but it's one of those things where it has its own reporting system on there. It's reading me. I have it set up right now. It's constantly pinging me every couple seconds what my temperature is down to the 100th of a decimal point. So it can go into that detail. You can hook up not even a Raspberry Pi camera, any camera. You got a webcam that's just sitting out doing nothing, hook it up. You can 3D print you a mount, and you can mount it up to show you a live feed into your 3D printer. Like if you're not at home, you're connecting on someone else's. As long as your home network is live, you plug in that IP again, it'll still work. You'll log in with the account that you made. You can see into that camera live feed. And then you can go one step further. This is the best part, and this is actually the reason why I started down this rabbit hole in the first place, is I wanted to look at it on my phone. I don't want to have my laptop connected to a Wi-Fi at all points of the day, because how many times do we find ourselves without Wi-Fi? I mean, you could do a hotspot on your phone, but it's not the same. Why don't we just use the phone? Like, you just cut the middleman out in that sense.
Yeah,
So,
exactly.
so there's an app, and there's actually several apps which you can configure, and all they're doing is the same thing your URL is doing, where you're connecting through and verifying your credentials. You're just adding the added security level of connecting that API to your main GUI. So it's wonderful, because from work, not connected to it, I can look at my print and say, hey, my print has failed and it is now spitting out just hot plastic. I need to stop this, save my filament. Honestly, right now, I can't clear the bed without like actually being there, but those are the next steps in the process, and the project is to get to that point. But Octoprint is the image. Octopi is the image. Octoprint is the service. And then if you want to expand, I bought 3 more printers. Okay. They can all get ran on the same Raspberry Pi. You don't need to buy a Raspberry Pi for each one. Of course, it's going to depend on how much RAM you have. You can't do 7 printers on 2 gigs of RAM. That's ridiculous. But you can run a couple instances of Octopi and connect a couple webcams, and you can have it all ran on the same interface. So it's beautiful, because future-proof. Back to our main theme is I want to protect the future of this. So if something's messed up and is continuously failing this print, or it's going to keep the printer's going to keep doing what you told it to. It's not going to stop until you say stop. So if it's hitting something and it's failing, it's going to keep hitting that thing until it thinks it's done with that print. So you don't want that damage. I don't want that damage. Stop the print.
Yeah.
So, and I can get more of the other plugins and things like that.
And
but-
this is why we like the Internet of Things.
Right.
This is why we like MQTT, and this is why we like the unified namespace. It's because I don't have to poll. I can say, hey, I want this to be defined, and when that value happens, subscribe to this broker and give me the information. That saves you bandwidth.
Yeah.
For me, when we're talking future-proof, you build this intelligence into the machine. I shouldn't have to. The camera is awesome. We can use the camera, and it's good to be able to have some type of supervisory in real time that we can look and see what's going on. Maybe I can make an adjustment from my phone. It'd be good to see where I might be starting to get off. But just like with scenes and intelligent devices we use for security, why can't we have that same type of technology built into a device that's being used as a standalone application to make a print? Hey, my print should be this, verify that my print is that. Maybe I don't use just the camera. Maybe I set up a system where I use cameras and infrared scans this device, and that infrared tells me if it's within the parameters of my STL file that I put into the machine that's actually being sliced. Maybe I'm going that way. Maybe I use some augmented manufacturing techniques where I say, hey, this is what I'm supposed to have. This is not what I'm supposed to have. If I keep on this path, this printer will fail at here, abort. So these are some things we can build in AI, machine learning, Tensor, TinyML. Start using some of these devices with Raspberry Pi, which are being done in Python.
Right.
We start to leverage these devices and build that intelligence and that future proofing into the application. The same with the mechanics. Don't purchase a NEMA 17 because that's about what you need for a 3D printer. That's big enough.
Yeah.
But don't purchase one that has only a few milliamps. Purchase one that's at 2 amps. So if I ever need to work in that range, I can. You factor in your 30%. You factor in your 20%. And Nick can talk about, future proofing things by building it good or building it robust in the beginning. Not waiting till the end to start building the robustness into it.
Yeah, and the thing is, when you talk about, pre-building your future proofing, it is, kind of where you're going at. It's, build it right from the beginning, but overbuild from the beginning. Like you said, if you know you're going to use 2 amps, or you think you're going to get to that point where you use 2 amps, damn it, build it to at 2 amps. Don't build it for, an amp and think, we'll get to it later. Because it's going to fail in the long run. However, and this goes back to the MQTT thing that we were talking about. If I can take all that data and dump it into a freaking, data pool, I can go back and see exactly what's going on at all times. So then I can use, AI and machine learning to look at that and kind of, look at a pattern of life. I can see, is my system failing? Is it going to be on time? However, but that goes back to the fact of, pre-building the system. I want to, future-proof the system from inception. I don't want to build a system just to build a system. I want to build a system that, we have more RAM, more storage that I'm ever going to need for the first year or two. I want to be able to plan that I'm going to have that thing ready for year 3 or year 4, and then if needed, upgrade from there. It's like, constantly using, Hyper-V and stuff like that when you have, ESXi you can run on the server someplace, and go that route. However, but that's also going back to the fact of, okay, well, why don't I just build an entire, lightweight Linux server and run Docker? It's one of those things. Why can't I have my Dockers auto start when I have failures? But that's future proofing on a system standpoint. We're talking about hardware and stuff like that. Everything is either hardened, but ready for extreme duty use, and and then everything else is either upgradable or to the point of where we haven't built it past that yet. Because I'll tell you one thing, if I start seeing a NEMA 17 with 3 amps on top of it on a 3D printer, we got some other issues to discuss. Because that thing is now flying.
Or on fire.
But the one thing I'll tell you this is I hate to see the freaking power supply.
Oh, man.
You have a 1,000-watt power supply that all it's doing is printing out a Benchy. It will probably be the world's fastest Benchy, but it will be a Benchy.
Yeah, and just to be fair, most stepper motors would never reach their max capacity because it depends on how you use the stepper motor. A stepper motor, maybe used in a CNC application, might reach those amperages, but never with a 3D printed application. It's not enough. You're not doing enough duty cycle things to reach that. If you are, you undersize the stepper motor.
Okay.
Yeah.
Literally, you made the stepper motor a few milliamps.
Mm-hmm. Either that or your 3D printer is on the fritz and it's doing something you don't want it to do.
Right.
Exactly.
But that's where future proofing comes in.
Yeah. Right. One of the last things, because I don't know how much, I think we're getting close to the time here. One of the last things I wanted to kind of chat with was kind of getting to something we've kind of talked about before, but not really dove into too much is, so we talk about other uses for G code. What other applications, in an industrial environment use G code? You've got your engraver, your CNC machines. You've got, in some places, the laser engravers, and then of course your 3D printer. I know that there's one printer out there now that's doing all 3 of these things in one package.
Mm-hmm.
I don't think that's enough because I also, first off, don't like the price.
Yeah, no one does.
So
That's
it's
a little ridiculous.
It's a pretty penny for that, but I
For a
think
hobbyist, too.
Yeah, on a hobbyist level, if this is industrial wise, I can justify spending thousands of dollars. If not, oh man, you better really like this hobby,
Right.
or have a good day job. But my thing is that they're all reading the same thing, so they had the right idea. Why can't it be done in one place? Now, every innovation has been more expensive when it first came out. You know, electric cars, blah blah blah. This, to me, is the next logical step in the evolution of a 3D printer, is for it to be able to have that plug and play. I think Ed was actually talking about it earlier today. It's funny you mentioned it because I've been thinking about that. Is if I want to do engraving, why can't I unplug the hot end there and plug in, you know, the laser engraver, a laser, or for a Dremel or something like that, something along those lines. Like, why can't we do that much easier? Why is there not an exchangeable piece? And then to get to how it relates to future proofing is now I've got the 3-in-1. Like when you got your there was 2-in-1s. I don't have a good example right now. Oh, actually, ex-girlfriend.
Like a printer?
Well, yeah. I mean, I'm just saying. I'm just trying to give an example where 2-in-1 is not better than each one doing it separately. So a 2-in-1 is going to be good at two things, but each thing is going to be a little bit degraded, as opposed to if you've got two things separately that does one thing amazingly, right?
Yeah.
So right now we have it, each one exists independently, and they're doing something that's great. They're making things.
Yeah.
So two of the things have the resolution. One of the things doesn't.
What's that?
And 3D printing does not have the resolution. With the laser, I can get the resolution with etching.
Okay.
With subtractive manufacturing, CNC, I can get the resolution that I desire. You can do that with a printer that has a scanner. I can get that resolution. Okay. The issue with 3D printers are mainly, we're talking about filament related 3D printers. Resin is growing in the hobbyist area. Still a long way to go. But that's the issue. It's the resolution. I have not been able to find a system that can easily get me to a resolution of, if I put it in a CNC machine and I mill a bracket, that bracket comes out almost perfect, with the exception if I need to anodize it or polish it. In the polishing phase, it's a lot easier as opposed if I had to do it with, when we're talking filament. Filament is different. You will see some layers.
Yeah,
I don't care how small a nozzle you use or how slow of a speed you use. It's just the fact of what we have at this moment with filament. Resin is a little different, but that's just where we are, in my opinion, far as if we're talking doing all 3-in-1.
Yeah. No, I agree.
Yeah.
I'm just thinking that's the next logical evolution of it.
Oh, it should definitely go there.
It should be. They exist separately right now. I don't see why they couldn't exist as one besides the sensors, which I agree to, because the current camera 3D scanners that are available for $700-800 are scanning objects and only doing minimal polygons. So that makes sense that it's not in a resolution standpoint ready to go. But that's, next steps.
But that's why the hobbyist market has.
Yeah.
it.
If you think about it now, most of your phones can do that.
That's why we like
You
open
know,
source.
but you're going to pay $1,300 for a phone that can do that.
Yeah, that.
So would you rather pay the $800 for the thing that do it on its own, or have something that can be a cell phone and a 3D scanner at the same time?
I think the key to both of this
Can I have it in the printer?
for all of us,
That'd be better.
Yeah.
open source. Open source
there
is
you
the
go.
key.
Yeah.
Open source in the hobbyist market, the people that like to tinker, I mean, that's where the enthusiasm is. They are the people that'll do all this testing and tinkering and come up with some of these things and test it.
Now let's think about that real quick, because I know we're getting close to time, and I'll go ahead and turn it over here in a second. We start talking about open source. You've got to make sure you talk about FOSS. Free and open source.
Yeah.
Open source, you're still dealing with possible paywalls and all this. You may get the code for it, though.
No, I mean,
But but paywalls, and now you got to go pay like Joe Schmo in some other location to unlock that functionality for you, and send you a license key. What we're looking for is stuff that's FOSS, free and open source. Because right now the only way you can future-proof something these days is to get into the free and open source realm. There are people who know how to do this stuff a whole lot better than the rest of us do. We just haven't capitalized on them yet. It could be some 10-year-old in freaking middle of Madagascar or someplace who's got a hand on a freaking 3D printer and a laptop, and that dude now can figure out how to do better than all of us. You got these people in all these other countries who do stuff better than most people here do. The only problem is it's untapped potential, and those people are the ones that are figuring out how to future-proof this stuff. Yeah. And but that's a good thing about having the we talk about all the time, the audience that we have. Who knows? Some of those guys or gals who are listening to us, they may be the ones who come after us and figure out how to make a future-proof 3D printer or a future-proof system that can overtake what we currently have. And also take that future-proof system and make it affordable. Because everything starts out expensive and goes affordable, like what John was saying. But, the thing is, it doesn't always have to be that way. Yep. But, the thing is right now it's capitalizing on people. It's, reaching out, STEM hands, open and stuff like that to, bring people into the world of STEM and get people invested in it and wanting to be part of it. And now I think we kind of hit that point where, it's, hey, we're welcoming you with open arms. Tell us what's going on. Help us help you.
Yeah.
And, with that, I'll say this, I think everybody who listens to us, globally, we're looking at the statistics today, and it's, seeing where we're getting listened from, we say thank you. If I could say thank you in all your native tongues, I would. However, I could barely have the language that I got now.
Still working on English.
So yeah, that was still English part is still freaking kicking my butt. But we'll get there. I'd say thank you to everybody, and hopefully we'll see y'all soon, and hopefully get some ideas from you. But I'm going to turn it over to whoever wants to take it, and we'll leave you with the the charge of the day, and hopefully we'll see y'all later.
So I think we're going to let Champ give the last word. So I'll just say this: who would have thought in 1970 that, or in the 70s when I was watching reruns of Star Trek, that I would see a flip phone? So for me, I've seen things advance from science fiction to science fact. So I think the big thing when we start talking future proofing, we're talking about people carrying the torch for the next, the next iteration of whatever device. And I'd say it's no better person to take us out than Champ.
Oh, I appreciate that. I mean, first off, again, I think I say it every week. Thank you guys, because I don't have the platform. I didn't have the platform before to even speak on these things. So all these ideas or this knowledge just lived with me, and I just kind of talking myself into oblivion, or my brothers actually, because they're kind of the ones who started me on this. But there's a couple themes that we talked about that I've had with me since before I started, studying physics. And actually, I found it while I was studying physics. And there's a something that Stephen Hawking said, and he said, "Well, it was, I only got to the point I am today, standing on the shoulders of giants," and that meant so much to me because he could only do his science and his physics because of Isaac Newton, because of Galileo, because of Einstein, all those that came before him. So for me, it's the same thing. The only reason I can do these things is because of the people who came before me, and the only thing I ask of those that come behind me is that we continue this knowledge. So that's all I really wanted to say. And if you have any interest in any of those books that those authors have, even if they're old, they're still worth reading, because that's the knowledge that still applies. So thanks, everyone.
Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanara.com. Hope you have a good rest of the day and continue learning.